Here is another word problem that's going to be asking us for equivalent linear expressions. So here is the word problem. I will read it. Lacey is hosting a movie marathon over the weekend. There will be P people at the party altogether. That means P number of people. It's how many of the people there will be. Let me start over. Lacey's hosting a movie marathon over the weekend. There will be P number of people at the party altogether. Lacey estimates she will need 1 bag of cheese popcorn and 1 pack of gummy worms for each person. A bag of cheese popcorn costs $2.50 and a pack of gummy worms costs $1.50. And then the question is, pick all of the expressions that represent how much money Lacey will spend on cheese popcorn and gummy worms. Okay, so let me go back and see what they've told us. That P equals the number of people. That we have cheese popcorn. And we have gummy worms. And they told us that the cheese popcorn actually cost $2.50 and the gummy worms costs $1.50. And we want to have one of each of these for each person. So even if let me just kind of draw a little picture here. If this is going to be my one person, I want each person to have the cheese popcorn and the gummy worms. But maybe I don't need it to look like that. I want to equate it to being my one person is going to have something that is going to cost $2.50 and $1.50. So now you have an idea of what we're doing. So let's go into their choices that they've given us. And they gave us an equation that is 2.5, actually an expression, 2.50 times P plus 1, close parenthesis, plus 1.50 times P plus 1, close parenthesis. Let's go ahead and simplify this. And whenever you see a number on the outside of a parenthesis with addition or multiplication going on inside, go ahead and distribute. So I'm going to distribute and do the multiplication. So 250 times P becomes 2.50 times P plus, what's 250 times 1? It's 250. Then I'm adding, and I'm going to do the same distributive property. 150 times P is 150P, plus 150 times 1 is 1.50. Now I'm going to look for like terms. This 250P can be added to the 150P, which gives me $4P, plus 250 plus 150. The 250 and the 150 are like terms, so I can add those two together. So that gives me just plain $4. Now, I can't go any further here because these are no longer like terms. So that's as far as I could go with that choice. I'll just put a letter A there. Okay, then letter B. Letter B would become, I'm even going to put letter B over here. Letter B is just an answer choice of $4P. Okay? And I'm going to make this one be letter C. And letter C is going to be 2.50P plus 1.50P. So let's see, I've got two sets of like terms. I can add them together. The 250 plus the 150 gives me $4, and I have to include the P's, and that's as far as it goes. And then I've got the last choice, which would be D right here. And that is P times 2.50 plus 1.50. And so at this point, it is the distributive property, and I could distribute it to both of them, but I also have like terms inside the parentheses, so I should do that first. This gets me to 4. So this would give me P times the number 4, $4. So then I can get rid of the parentheses, and it would look like $4 P. And at this point, I can see that these three are exactly alike. So in reality, these would be my answers to which ones of these equations or expressions are equivalent. But at the same time, when you look at this choice, letter A, when we went back up here, we can see that each person I was going to spend $4 on. So just from my picture, sometimes drawing pictures really helps. And so this is what we ultimately wanted, which is exactly what we've got. However many people times this $4 is what we're going to spend. And that's what each one of these tells us.